you might have individually. So that is the process, or that is the procedure which I'll be following. So is it clear to everyone?
Yes, sir.
Okay, thank you. For your information, recording has commenced, and only thing is I'm still an attendee, so I'll just wait till I become presenter so that I can present my PPT or the whiteboard as the case may be. Okay, so let us see first of all the topic which we are starting today. As we have seen, it is based on the Anybody wanted to say something?
Sir, attendance, sir.
Attendance will be taken automatically as you have logged in and you kept your videos on, so it will be taken those who are here.
Do we need to keep the camera on or for attendance or what?
Only for attendance part.
But till what time we can keep it on?
Initial 5 minutes is okay. So now you can switch it off if you want to. If you have enough bandwidth for your internet, it is up to you. If you want to.
But it was not informed to me, sir. तो अभी क्या करेगा?
You have logged in, na? It's okay.
We have logged in.
Yes, I think it's all okay. No problem. Let's begin the session. So let me initially let me just open the PPT and then we will I will switch to whiteboard while dealing with the numericals. I think some of you have not muted your mic or the audio part. So during, let me just explain to you. I think in your orientation class, it must have been told to you that during the lecture, please keep your mics off. Keep yourself muted. However, at any moment, if you want to ask anything, either you raise your hand as has been explained to you, or you can unmute and speak, but otherwise keep your audio off so that there is no disturbance in the class. Is it well understood?
Yes, sir.
Okay. Now, as you can see on your screen, I have opened the PPT, which must be visible to you. You have to just confirm that yes, any one of you unmute and tell me yes, it is visible.
Yes, sir.
Yes, sir.
Thank you. So this is the first part of our EK numerical portion. Although for the newcomers, there are various topics which will be coming on a weekly basis during your course. So this particular month, this is as far as I am concerned, I am taking a number of topics with you. So numericals is the topic as far as I have to deal with. Now we have to, following things will be covered in the initial stages. One is the admiralty coefficient. What is admiralty coefficient and what is the meaning, how we make use of it. And we will see, it is just a scope. I'll be explaining each and everything out of this. Fuel coefficient. Then there is a relationship between fuel consumption, displacement and speed. So we'll have a look on that relationship. And on the basis of admiralty coefficient and fuel coefficient, the first two coefficients which are there on your screen, they will be used to calculate the daily consumption at service speed. So when the vessel is sailing, how much fuel will be there in tons? Consumption is measured in terms of tons per day. The bunker fuel required for a voyage. So for a particular voyage, how much bunkers will be required? Because the stemming of bunkers is based on this calculation, and then accordingly we intimate to our owners or charterers that this is the bunker requirement. So we'll calculate under different examples the bunkers required for a voyage. The speed for a given daily consumption. So we can also see that for a particular speed, what will be my daily consumption. A vessel operating, let us say for an example, at 50 knots, and I want to know what will be the consumption at 80 knots if I increase. Using these formulas, I can calculate what will be the daily consumption. Similarly, we can also calculate the speed which will be required to complete a voyage with a given consumption. Many times now we know that we have a certain amount of bunkers. Let us say 2,500 tons is there on board, and we know this is a voyage distance remaining. For example, even out at sea, suppose we know that so much is the distance to go. At what speed should I proceed so that I arrive at port with sufficient bunker? Sufficient means that bunker on board at that time should be sufficient for the vessel to reach port. And what will be ROB? We consider that this is unpumpable. So which is a practical thing on board, that certain amount of fuel at the bottom of those big tanks remains unpumpable. However small it may be, but it is definitely a quantity which may be 20 tons, 10 tons, which may be, it varies from ship to ship, and also varies from based on trim. Sometimes with a good trim it can be transferred. So these are the various possibilities where we need to know how much bunker should be there or how much speed we should move with so that we reach safely. So this is the concept we will see, and we will also, let me first let me just open the whiteboard to see the relationship what we want to establish before we start with the actual formulas. So let me just unshare this, and I would like to share a whiteboard so that few points I can write here.
सर स्क्रीन थोड़ी सी ब्लर हो रही है, आपकी वीडियो भी थोड़ा सा रुक रहा है बीच में.
Because that I had changed the slides. That is why sometimes your internet, depending on the speed, it settles down in a little while. Okay, now can you see the slide, which is a whiteboard, and it must be steady now. I'm just adjusting the screen so that I can write a little bit. Yeah. Now, okay. Now let us see. When the vessel moves in, of course, always vessel moves in water only, except when the vessel is in dry dock. So we have a certain draft, correct? Of course, here you will have the propeller and the vessel is moving in this direction. So there is a resistance offered by water to the movement of the vessel. Correct? So this resistance depends on various factors, including the speed. So let us say the vessel is moving with speed v knots. And if I say RT is the resistance, RT. Now this is in newtons. We have to also consider the units very carefully, because in numericals we have to use correct units. So as we know, the unit for the speed is always, in marine field we are using knots. However, ashore it may be so many kilometers per hour, like that, but on board we are using knots. So knots, as you know, is nautical miles per hour. This is the meaning, so many nautical miles per hour. So we'll be using conventionally knots. However, when we calculate the power, because power in metric units is expressed in kilowatt power. The units are kilowatt. Although we can have watt also as a unit, but watt will be a small unit, and since the power involved is large, kilowatt is the one which we use. So when we use kilowatt as the unit for power, and if we have speed in our relationship while calculating power, the speed we cannot use in knots, because all the parameters in a particular formula must be in the same units, whether it is MKS unit, FPS unit, or SI units. What we are using is SI units, correct? So here we will be using the speed for the units for speed will be using as meters per second. All right. So I will, as we go about these formulas, I will explain to you that most of the formulas we are using V as knots, but whenever I have to calculate power in that formula, we will have to convert that speed from knots to meters per second, because power is nothing but rate of doing work. So we have to see what is the work done per unit time, and in SI unit time is in seconds, and the linear dimension is in meters, force is in. So these are the, we will be using force will be in newtons, distance in meters, power we have already written here anyway, so kilowatt, work done will be in Newton meter. All right, so Newton meter if I am using, and if we use Newton meter per second, will give me watt, and if I use kilonewton, so power we can say should be in kilonewton meter per second is kilowatt. So 1 kilonewton meter per second will be 1 kilowatt. So I'll be re-emphasizing this, and I'll be repeating the same thing as we keep doing. And from formula to formula also I will explain which unit is applicable in this particular formula. And I would advise you to keep one or two pages in your notebook or exercise book, so that as we are discussing the various formulas, for solving these numericals, we keep writing in a chronological order. So by the time we finish with these numericals, you will have all of them in one place. And then for revision, you just have to go through that 1 page or 1.5 page with all the relevant information. That means the units, which parameter has to be used in particular unit, whether it is meters or speed is in knots or meters per second. So that will be a ready reckoner for you, and then you will save time during exams, because then going through the entire book is not necessary. You would have already done the numericals in the class. All you need is just a refresher at that time and go through the formulas, and you know which formula to be used for a particular type of question. So that should be our approach. Okay, coming back here now to this vessel. Now, when the vessel is moving, you must have also heard about towing tests for the models, correct? There also the model is towed in a tank. That is why it is called tank test. So then there is a resistance for the model when it is moving in water. This resistance we call as RT. RT represents the total resistance. So this is the resistance offered or experienced by the vessel because of movement in water. So this resistance, should be the unit of measurement, because it is resistance is a force, and therefore its units will be, so units will be Newton, because Newton is the unit for force, or kilonewton. So 1000 Newton is 1 kilonewton, and accordingly we can use Newton, or both are okay. But only thing we have to see that in a particular formula, if I am using for power calculation Newton, my answer will come in watts. If I use kilonewton, my answer would be kilowatt, but that we will see later. So force, unit of force is Newton, and that is how we use this either Newton, which is represented by simple letter N, correct? N or Kn, kilonewton. So this is the resistance. Now let us say the vessel is moving. Vessel moving at V knots. In all these numericals, we will be using a certain alphabets, and we'll keep using the same so that we know this represents so and so thing. Instead of mixing and using different alphabets for expressing a particular parameter. So here speed will be always V. Now what is V? V is the speed of the vessel in knots. Speed of the vessel in knots. This is capital V over ground. Correct? So whenever we have to use this term over ground, speed over ground, and I'm sure you are all familiar with these things because you're using it on a day-to-day basis. So I don't have to explain too much on that. So V is the speed of the vessel in knots over ground. So anywhere we use V, you must interpret it like this only. Okay. So now if the vessel is moving with V knots and the resistance, which is RT, so let us say V is, for example, this is example. For example, V is equal to 15 knots and RT is equal to, let us say, 1200 kilonewtons. Because we the forces are not so small, so we are always normally using kilonewton as the unit. So if this is the case, that means the resistance RT, total resistance of the vessel when operating at 50 knots is 1200 kilonewton. Which means if my propeller here develops, if propeller develops a thrust of 1200 kilonewton, vessel will move with at 50 knots. This point should be clear. That means when the resistance at 50 knots is 1200, which is just an arbitrary value I have taken. That means the propeller, if propeller is giving me 1200 kilonewton force, the thrust which is created by the propeller, the vessel will move at 15 knots. So that means I can use, there is a relationship between the thrust and the power. And my engines are somewhere here, if you know, of course, you know, the shaft is coming here. From here you have the intermediate shaft, and then coming out you have tail shaft here, and then the propeller. And that is how this propeller is creating a force or a thrust which is measured. Since it is a force, will be measured in Newton or kilonewton, right? And that force we are talking about, if it is 1200 kilonewton, which which is exactly as the resistance between water and steel of the hull material, then of course we will have this. If the propeller gives me this thrust, we'll have this 15 knots speed. So that is the one basic thing. Now we come to the second part of the same thing, is that, let me just rub it off. If you want to note down anything simultaneously, you must scribble through with your notebook if you want to write something so that you remember for later use. Okay. Now this total resistance, just a second please. The total resistance is expressed as sum of RF plus RR. This RF is the frictional resistance. RF is the frictional resistance. Now you must have seen that every time during the dry dock, we are cleaning the hull, removing all the barnacles and the sea growth. We do the blasting, grit blasting or sand blasting, and then paint the hull. So all that falling on the hull increases the frictional, that is how this frictional force or the frictional resistance is increased, and that is how once we clean it, the total base resistance, frictional resistance reduces. So if the hull is fouled, you will find the resistance increasing, and if the resistance increases, more thrust is required by, or more force is required from the propeller, and obviously more power from the main engine, more fuel consumption. So that is how they are related. So hull fouling increases the power required to propel at a certain speed, which we are saying v may be any value for a particular v speed. If there is a fouling, the frictional resistance will increase, and then of course the power will increase, and therefore consumption will also increase. So a clean hull obviously is necessary so that we consume minimum fuel from the point of view of energy conservation, from the point of view of cost factor, and from the environmental pollution as well. Now, second part is called RR. So RR is called residuary resistance. Also sometimes called wave making resistance. Now, wave making resistance or residuary resistance means there is some, as the vessel moves, some waves are created, and we are not talking about the waves which are created because of wind or swell or any other thing. They are external forces. We are at the moment only concerned with the waves created because of the movement of the vessel, even if it is a lake, correct? You must have seen while going in a boat in a lake, as the boat moves, still you have waves created. So let us not confuse with the waves because of the external forces. We are talking about movement of the vessel. So the waves created, from where the energy is coming? The energy is coming from the vessel only in order to create these waves. That is why the term used is wave making resistance. So in terms of the total resistance, this is the second factor, which is called a residuary resistance. And sum of these two is called the total resistance, as we have seen in the equation 1, frictional resistance plus residuary resistance. This total resistance is what is required to calculate the power required by the ship's engines to move the vessel at v speed, because this resistance is corresponding to speed v. And power, although too early to give this formula, but anyway, power is RT into V. And if you see here, and this will be in kilowatts, ship's power, I mean the main engine power and even the generator powers, they are all calculated in kilowatt. You must have seen in your ship's particulars also. It is mentioned so much kilowatt is my MCR and so much is a CSR. So accordingly, this is given in kilowatts. If you just break it down, and RT is in, let us say, force, this is a force in kilonewtons. If I write here, so that instead of writing this capital V, which I gave you, indicates the speed in knots over ground. So if I keep writing that capital V everywhere, there will be some confusion. You will not be able to know whether the V here means knots or means meters per second. So that is why we use this as small v, like this. So V is, RT is in kilonewtons, V is in meters per second. And therefore, if you only write the units, kilonewton into meters per second. So what is this? Kilonewton meter per second. Kilonewton meter is what? Work done. And work done per second is power. That is the basic definition for power. For example, if I apply unit force to move it by 1 meter, I will say if 1 kilonewton force is required, I'm applying and moving the object to 1 meter. So that means 1 kilonewton meter. This is the work done, and if it is done in per second, if I calculate, this will be the power. Rate of doing work is power. So anyway, coming back to this formula, instead of writing capital V, I would prefer to write a small v so that we know that here it is meters per second. All right. So power RT into V. Now this RT are frictional resistance and residuary resistance. These are the two resistances we have mentioned. So we will see what are the components of these frictional resistances and residuary resistance.
सर एक बार आरआर दोबारा बताएंगे, रेजिडुअल रेजिस्टेंस.
Residuary resistance is the wave making resistance, because as the vessel is moving, you will find the waves created, correct? So that because now these waves cannot just start appearing on its own. And as I told you in the beginning, we are not talking about any wind or swell causing these waves. We are talking about wave creation because of the movement of the vessel. I will further explain this residual resistance in a moment. Right? I'm coming to that.
Okay,
But we have to remember that waves are created because of some energy, because the waves carry energy. So they have been imparted to water to create those waves, and that is coming from the ship's engines only, correct? And that is how the engines are causing the thrust on the propeller and the hull is moving.
okay.
So that wave making resistance is the residuary resistance.
Okay.
Right? And sum of these two is the total resistance. And if I know the total resistance of the vessel, then I can calculate what is the power developed by the vessel or ship's the vessel's engines. They are developing so much of power, RT into V. And V here, as I said, will be small v we will be using simply to represent, although V is also speed, but speed not in terms of knots, because I have to have all SI units when I calculate power. Correct. So that is why RT I am keeping it either in Newton or kilonewton. Both are part of the SI. And small v will be meters per second. Kilonewton meter per second, which is the work done per second, is the power. So this will be how we calculate. Okay, coming back to the RT components, frictional resistance. Frictional resistance now I am using a sign proportional, which does not mean equal. Equal to and proportional sign, as you know, is different, because a thing can be proportional to. If I double it, it becomes double, or 1.5 times. That is linear relationship, that is proportional to. But when I want to make it equal, I will have to introduce a constant, correct? Otherwise, it only means it depends on or is proportional to the length of the vessel. Also, it is proportional to wetted surface area. Normally we write it as S. We use the alphabet S to represent the wetted surface area, which is the underwater area of the hull, is also proportional to the speed of the vessel. More is the speed, more will be the frictional resistance. Is also proportional to the density of water. Now we always check for various reasons the density of seawater. Now let us see for our numericals. For our numericals, I will take this as 1.025. यहाँ पे decimal है 1.025. I am very well aware that when you are calculating for doing the stability calculation, you are taking the exact one, but here, unless given in the numerical, I would assume to be 1.025. So if I calculate the total resistance or frictional resistance uh, in fresh water will take it as 1. Then to calculate for seawater, I will simply multiply by 1.025. So this figure I'm sure you know it, but just refresher, keep it as handy somewhere. This is what we'll be using, simply because it is directly proportional to the density of the water we have seen. So if I know in fresh water and I want to know in seawater, I will multiply with this. Also, the frictional resistance depends upon the roughness of the hull. Roughness of hull, which means, as which we have discussed earlier, that if we have the fouling of the hull, we have the barnacles or other deposits, and then the frictional resistance will increase, and the propeller will have to provide more force and more power, obviously, for that purpose. So these are the factors on which the frictional resistance depends or is directly proportional. All right, so now we will see the second part, which is the residuary resistance, correct? So frictional resistance, I hope, is clear to everyone that these are the factors on which it depends. So I am erasing using the eraser this part so that I can write here RR part also, residuary resistance. Residual resistance comprises of three components. First one, let me just make it here. I'm looking at it's just symbolic. Please don't think that this is the shape of the vessel. This is to represent exactly what we are trying to understand. If the vessel, I'm looking from the top, if this is a vessel, as the vessel moves in the forward direction, just a second please. Good morning. अच्छा अच्छा अच्छा, आज ब्लॉक में है, ओके ओके, ठीक ठीक है, हाँ हाँ ओके, ठीक ठीक है, ठीक ओके. Okay, so let us see the first one. Now, if this is the movement of the vessel, and these are called the streamlines, formation of streamlines across the vessel. Now, just imagine if it was a flat front, just in case of a barge. Now you see this will be like this. So the resistance will be more. So first one is resistance due to formation of the streamlines. So this will depend upon how the vessel is profiled, correct? But as I said, just two examples we have seen. One is like this, one is a flat front. Here the residual resistance, because the energy is required from the vessel to create this, and that is why we call it as a resistance due to formation of the streamlines around the vessel. This is one component of the residual resistance. Then second one, we say formation of eddy currents. Okay, let me write due to. Resistance due to formation of eddy currents. Now, eddy currents, we are looking at the cross section of the vessel from forward to aft. Correct? Anywhere, if there is a change of cross section, again I would say I'm not drawing the shape of the vessel, but just to represent lengthwise, anywhere you have the change in cross section. For example, if there is a cross section change like this and another place like this, eventually the vessel is. So these are the local at particular point. This is again the center line. These are the eddy, because the water will flow like this. Although these were different, this is eddy currents. Similarly here. So because of this is the resistance because of formation of eddies or eddy current as we call it. This is the second component of the residual resistance, only wave making resistance as we are calling. Then third one is formation of, here I can write here only, formation of waves. Now what waves we are talking about? If you see again, let us now I will be looking at the end view just like we saw in the first one. Now when this vessel is moving, so first two we have covered. Now because of this we also, because it does not move on tracks or anything, it is moving in water, so we will have these waves created because of this movement, correct? So this is the third part, which is formation of waves because of the movement of the vessel. And combination of these three, the energy basically, if you see the concept that we require some energy which is coming from the ship's propulsion system to take care of these three. Total of these three is what we call as a residual resistance. And now let us see, let me just first erase part of it. So we have back to the first formula, which says that the total resistance is sum of frictional resistance and the residual resistance. Now for slow moving vessels, the frictional resistance is dominant. That is a major component of the total resistance. Correct? This is major part and this is a minor part. And therefore, we are more concerned about better hull profiling, and so that and cleaning the vessel clean always. Plus, so this is a dominating factor at slow speed vessels. Whereas at high speed vessels, this becomes a major part of the total resistance, and it can be maybe between 40 to 60% of the total resistance. And that is why, in order to reduce this factor, you must have seen we use in many cases the bulbous bow. So this is only for the purpose of RR, residual resistance, to reduce this residual resistance for fast moving vessels. Although by providing this bulbous bow, we are adding little more wetted surface area. So we are adding little more frictional resistance, but the benefit of reduction in wave making resistance is larger, and therefore we get benefit by using this. Anyway, total resistance, as far as we are concerned, is sum of these two values. So RT. Now we will come to a relationship which will say total resistance RT. Let me just use the top part also, because this may not be sufficient in establishing. What we are going to establish now is the term which we call as admiralty coefficient. You will find this also being asked as sometimes in a part A and small definitions, admiralty coefficient, fuel coefficient, and similar things, and B part numerical. But mostly we have numerical. So again, it will depend on. So if the short note is there, then you will have to express ki kya hai. So let us first see RT. RT is the total resistance. It can be expressed, or it is proportional to rho into S and V raised to power n. And this is a proportionality sign. That means not equal to, it is proportional to. It is proportional to total, or rather it depends on total resistance we are talking of now. Total resistance is based on density. If the vessel is in fresh water, the resistance will be, total resistance will be less. If it is in seawater, it will be more. It also depends upon the wetted surface area. More is the wetted surface area, more will be the resistance. And also on the speed of the vessel. So this is the equation number 1. Now S is the wetted surface area. ये किस में होगा? मीटर स्क्वायर ऑलवेज ना, यूनिट विल बी SI, मीटर स्क्वायर में होगा. If I write it in form of linear dimension में क्या होता है कि a length will be in meters or L, for example, area will be L into L and volume will be L into L into L. So we bring it to the most simple dimension. So S will be, if L is represents the linear dimension, S will be L square. S can be proportional to L square, correct? Not equal to S. It will be proportional to some linear dimension area. Well, so even if it is an irregular figure, we always calculate area into meter square. If it is a regular figure, if it is a square, it will be one side into second side. But even if it is an irregular figure, we can always represent in L square, so that L is equivalent linear dimension. Now, displacement is proportional to L cube. From here we can write L is proportional to, if I write this delta thing, I can write, if delta is proportional to L cube, then L is proportional to delta raised to power 1 by 3. And therefore, using this value here, I can say S is proportional to L. In place of L, I can write this. So I can write delta and square, and this is 1, 2, so raised to power 2 by 3. Which means I can rewrite this equation number 1 as RT proportional to rho, and S is delta 2 by 3 into V raised to power n. Now I'm just drawing a straight line here just to separate the two areas. Now I can, rho can be, for C order, can be assumed to be constant, approximately 1.025, and therefore I can bring, now if you see here, we still have to define n. N is the index which depends upon the speed of the vessel, and n is equal to 2 for slow speed vessels. Slow speed vessels, all our marine vessels are slow speed. So then it becomes that RT is proportional to rho into delta 2 by 3 into V square, and power is RT into V, so power is proportional to rho into delta 2 by 3 into V square into V. Why V? RT, as I said, is P is equal to RT into V. So this is RT, this is V, and this is small v's because V has to be in meters per second. So I can say proportional to, now if I take all constants on one side, I can say a constant, and I can replace this by equal sign, equal to delta 2 by 3, and this becomes V cube. P I have taken on the crosswise downwards power. This constant is called AC, or admiralty coefficient, is equal to delta raised to power 2 by 3 into V cube divided by power. So this is the relationship. So admiralty coefficient is the relationship between displacement. Now displacement here is in tons, and V is in we are using in admiralty coefficient V as knots only, correct? Because here we are not calculating power.
सर ये दोबारा से सर वो स्टेप बताना वहाँ से सर जो पहले सो पावर कैसे आ गया वहाँ से सर आरटी की जगह सर पहले आरटी था ना सर आरटी प्रोपोर्शनल टू
आरटी प्रोपोर्शनल,
फिर आपने पावर कर दिया सर उसके बाद नेक्स्ट
वो इसलिए कर दिया कि पावर जो होती है ना, मैंने इससे पिछले उसमें बताया था आपको, पावर इज रेट ऑफ डूइंग वर्क. सो फोर आरटी इज फोर्स, आरटी इंटू वी इज पावर. तो इसलिए पावर, लेकिन हमने इक्वल साइन कहीं नहीं लगाया है. सिंस आरटी इज प्रोपोर्शनल टू दिस, सो पावर विल बी प्रोपोर्शनल टू आरटी इंटू वी. आरटी इंटू वी रिप्रेजेंट्स द पावर ना. आरटी इज फोर the resistance, total resistance, and V is the speed. So using this expression, I have written power is proportional. See, power, I can write na, power is proportional to RT into V, क्योंकि ये total resistance पे डिपेंड करता है और speed पे डिपेंड करता है. तो इसलिए RT is proportional to this, therefore power will be proportional to RT. This is RT इंटू वी, और इसमें v स्क्वायर पहले ही था, इसलिए v स्क्वायर इंटू वी क्यूब हो गया, डेल्टा 2 by 3 हो गया, नीचे पावर हो गई, और ये जो रो था मैंने अक्रॉस इधर ले लिया, एंड आई एम एब्जॉर्बिंग दैट इन दिस कांस्टेंट. जब आप proportionality sign हटाते हो, so I have to introduce a constant. So that is why I'm making it equal, but introducing a constant. Then only I can put equal to. Otherwise, we cannot write this. Even here, I cannot write P is equal to so much. It is proportional to. If I am removing the proportionality sign, I have to introduce a constant. So that is how this constant I am saying AC, and this becomes delta 2 by 3 into V cube over power. This is my relationship number 2, which we will be using for numerical solving. Clear है? नहीं है तो अभी I have one more lecture with you in the I think afternoon या before noon.
पावर प्रोपोर्शनल टू डेंसिटी आगे जो अपने RT डिवाइडेड बाय फिर RT का दिया, उसमें डेंसिटी कहाँ कांस्टेंट के नीचे ले गए हो?
हाँ, अब अगर मान लो A by B is equal to C by D, तो मैं इसको इधर ले सकता हूँ ना, A into B is equal to C into B लिख सकते हैं ना, इक्वल टू साइन में. तो अगर ये if I am replacing the proportionally sign by a constant, I am moving P across ना, इक्वल साइन के across नीचे ले गया मैं, रो को इधर ले आया, रो को मैंने I am absorbing it in a constant. A constant divided by a constant will be a constant, correct? So rho is now part of this admiralty coefficient. Clear?
सर ये डेरिवेशन वगैरह भी पूछते हैं या फिर ओनली वी विल यूज इन न्यूमेरिकल्स ओनली?
ये तो 2 लाइन का डेफिनेशन ये आपको सिर्फ थोड़ा अभी इनिशियली actually it is only 2 steps. One step is RT is proportional to this. सेकेंड स्टेप में S और डेल्टा को गया है और उसको मैंने इसी फार्मूले में पुट कर दिया बस. तो 3 लाइंस. So in short note you can, if it is short note carrying let us say 10 marks, it is worth giving this derivation because it is only less than a minute derivation. There is no derivation, it is just proportionality sign को equal करके मैंने क्रॉस ले लिया और only this part we have done. Delta has been expressed as proportional to L cube on linear dimension basis. L is therefore delta raised to power 1 by 3 और इसलिए इस फॉर्मूले में ये दिस इज प्रोपोर्शनल टू S को मैंने इससे रिप्लेस कर दिया. V वही का रहा, N की वैल्यू 2 ले लिया हमने स्लो स्पीड के लिए एंड दैट इज हाउ वी गेट दिस.
सर वो लास्ट स्टेप से पहले हम मेंशन कर सकते हैं कि AC इक्वल्स टू कांस्टेंट बाय डेंसिटी, तो जब फिर प्रूफ हो जाएगा.
Yes, you can do, of course. You can make even K here. K ले लो फिर यहाँ K by rho कर लो. K by rho will be a density, so constant only. So then you can say, okay, this I am making into AC, or this is a constant for the vessel.
ओके सर.
ठीक है ना? Okay, so already late for the break, so we will take the break now and. Then we'll if more explanation is required, we will see it in the next lecture. Thank you so much.